Okay, so we're back with more development and didn't really get food, did get some tea, and did do various other things. Hopefully my headset actually charged in the very short amount of time I actually took the break. One thing I want to note, which is the reason I got the video folder open, is I don't know what I did, but I got the file size down to 300 megabytes in this video without compromising quality, which is strange. Hour-long video, 300 megabytes, decent resolution, decent quality, not horrible audio problems, which means uploading is much quicker, and no clue why, because these videos are on average somewhere between 2 to 5 gigabytes when I make them. So that's good. If it maintains that type of file size, I'll be happy. Although the reason it probably is that way is we didn't launch Minecraft that entire time. As soon as you start involving a high frame rate application, with a lot of transitions between movement and stuff, I think the file size dramatically goes up. We'll test that theory towards the end of this video, where we'll check the file size right before we stop. At least I hope I remember to do that. I'll probably forget, and if I forget, somebody just remind me in the comments and I'll check. So we left off, we got our main test working. We're going to implement a couple more tests that are JSON specific, if I can remember how to parse JSON here. Even though I work with JSON files a lot, I do not work with the basic level of them. I work with a lot of the higher up level stuff, which means I'm usually manipulating the data, not loading the data. So we're going to test JSON element handling. With this, we're going to want to make some more keys in our test object. So we're going to want to make a new method, and we're going to call this JSON element. So JSON element, and we're going to call this element. So we're actually going to use a more specific name. We want to test this on both our filled and our method. So we're going to make, this will actually be 2, and we'll call this element 1. And this will be a JSON element. And the reason we're doing this is we need to test to see if we can actually load up a JSON element properly directly into the system. It'll be rare that ever in our actual code we'll do this. The only thing I can think of is that something may want to process a JSON element, so we may have some kind of processing system. And that processing then has an injection method that goes, okay, this method is what handles our actual JSON element. And then that, when you get that handled in, then that actually parses that and deals with it and does other things. Unlikely we're going to have a situation like that. The only thing I can think of is if somebody implements their own custom JSON system and they want to handle it this way, preferred to writing processors. Theoretically, with this, we wouldn't have to write processors, but the processors were designed for reusability, so that way you can nest processors within each other in order to get a really nice result out of your JSON processing, which is what I kind of want to have happen. So we're going to test this. Then we just need to test each data type. This is going to be the boring part of doing this, and this is the reason why I don't show unit testing on YouTube very often, is because there's nothing entertaining about JUnit testing. It is one of the most boring things you will do as a developer if you ever get a job as a developer, because all it comes down to is do test, check test stuff. So you create a test, you create test variables, you test for those test variables, you confirm that everything works properly, and then you move on. And you got to do that with every single thing in your code, because the goal of JUnit testing is to get 100% coverage for everything you can possibly imagine. It's not a cover for everything, but just everything imaginable. So if you can imagine somebody sticking like a peanut butter and jelly sandwich into a VCR, you could test that. Now, given you can't actually test that in code because that's a hardware issue, but if you could test the hardware, you could create a system for that. And there actually are tests for hardware. I used to work for a factory where we did electronics. We had a system where you could stick the board into a tester, and the tester did something similar to JUnit. It tested every single component on that board that they possibly could imagine would have issues. And if it failed, the board came back to me because I was in the repair department, and I repaired the board, and we sent it back to the tester. I don't remember, I never got told what my success rate was, but it was rare that I had boards come back that I had repaired personally. though I did get yelled at a couple times because I broke a $200 chip, and I got threatened that the next time it happened, it would come out of my paycheck. Seeing as my paycheck was like $400 a week, that was pretty scary because that's half my paycheck. So we need to test. Wow, we gotta come up with. There's no easy way to do this. So we're gonna do int I. So we're gonna be the most laziest possible we can be about this. So we want an integer. We gotta define our type here too. Type equals int. This has to be value. So we're actually hitting the point where we actually have to define the value. So right now how these are working is by default when you pass something in, it goes directly to value if you don't define what it is. And I closed, there we go. So we're gonna do that. So we're gonna need an I2 because we need to test to see if integer, I think it's spelled right. We can actually test this. Integer, yeah, it's spelled right. So we got I2, so we got both of these, and this will be int2, and I hate to have to test both of these, but luckily I only need to test this once because it shouldn't fail in the method case. So then we got byte. This is going to be a byte. So we got byte and then short, so this will be s. I fell asleep doing unit testing once just because of how boring this is. It's pretty miraculous to think of that you're actively doing a task and then you end up falling asleep. I think there's only, in the rather lack of many jobs I've had, I've only fallen asleep on the job like 3 times. And every single time I kind of paid dearly for that, not because I got fired or anything, but of course I worked in the repair department, which means I worked with tools. I fell asleep and my arm hit a soldering iron one time. I got electrocuted another time, and I got stabbed by I forget the name of the tool. Basically, it was a scalpel-like tool, except it wasn't sharpened. I still got a scar on my face from that one. The other injuries healed, of course. That was one of the many times I got electrocuted on that job. Let's see, so we're testing our ints, bytes, short, long, float, and then we need a double. Oh, looks like my brother's finally home. Okay, so that's everything we need for the fills. I don't think I'm missing any data types here. So we are testing both of our integer types. Byte, short, long, float, double. Now I need to open up this just to confirm if I got everything. Yeah. We're good there. And we want to go find our injection class. So we're going to test all this. We just got to duplicate all this for the methods too. Okay, duplicate this for the methods. I'm going to copy all of this down here. Okay, so this is literally what we're going to do. Just pass this all down. The good news is, actually, I didn't think about this. No, actually, I need 2 methods for this. So there's going to have to be a 2 here. And this would be actually I4, and this is going to be I3. And these are all going to be 2 because we have to differentiate between all of our keys because there can't be duplicates. Although I don't think it actually checks to see if there's a duplicate in the method base. But we're going to keep them separated, and I'll deal with the lack of duplication at another time. So here's byte, and of course this will be B. And then this is short. By the way, this is an example of why you shouldn't name your variables like this, because it's now becoming a little more difficult to understand what we're trying to define. So in this case, I'm using single characters, and you should never use single characters. The only time it's acceptable to do single characters is if you're doing a for loop, and even then, if you can avoid it, because it will make your code so much easier to comprehend. Because if you read this code, if you didn't know what was going on and you're looking through all of these, how do you tell what's going on? You really can't. There's not a lot of information being passed back. But other than that, we've got it all set up. Now we just got to come over here and test a lot of bullshit. That's literally just how you call that. So element 2 is what we're actually injecting now. So this will be down here, element 2, and I have to go find one of my JSON systems. So we're going to copy this, because we got to create the JSON and then we got to parse it. And we're going to just create it down underneath here. And we don't care how it parses. Apparently this has got a super method. I'll probably recycle this stuff here later. Actually, you know what? I'll recycle it now. So this is it would be creating a system from a string. So let's see. We're in the test case. I want to go down here. We have a helper system that I'm starting to develop. The plan is, here's all the JSON loading content that came out of the JSON content loader. I separated it out because I want to make this code reusable so I can start to use it in my video game I'm working on. And in order to do that, you've got to separate out as much content as possible. And this will be moved to CodingLib once it gets abstracted out. And I'll move some other things with it. And there's a high likelihood that if I can make it happen, the content loader will become its own independent library that anybody can download for any application, because I'll make it open sourced and everybody can use it, because it is a powerful system when you think about it. It may not be the most beautiful and it may not be the most well built, because of course I'm lacking in experience in all this, but what it lacks in those is that the outcome, the result of the effect of what it does is it lets you take a JSON file and turn it into an object. And that doesn't sound powerful on its own, because I know there's people like, I can do that with JSON, I can do that with all these other libraries. But it's the way it does it. You have nested processors, you have injection keys, you have different ways to handle things. You have loading and unloading and all that other cool stuff that when combined with something like a game, it means that you can remove a lot of your content-driven data out of the class files. And the whole goal of an application is to process data, not to contain data. So you want to remove as much data out of your application as possible and move it to something else. This is an example of JavaFX. For those who are not familiar with, is a GUI system built by Java. JavaFX is built around the ideal of taking the GUI code out of your application and putting it into these little XML files. The XML files define how your GUI looks, defines how it functions, and everything else. It defines what methods to call, what fields to set, stuff like that. Now you still have to go in and code methods to tell it, like if I click this button, what to do, but then that's logic, that's not data. The data would be what method to call. And if you build up enough methods and you build up enough stuff, you have incredibly reusable code. And there are libraries out there you can download that will let you make a full application out of just XML data. And I've done it before. It's really good. One of my clients' projects I did with JavaFX, and it's a beautiful launcher. It looks nice, it transitions nicely, it functions pretty good. I mean, we did build over top of an open source platform, so there are still a lot of issues in the back end, but they'll get fixed eventually. But we're back to here. So we want to call this create element from string. Actually, we'll just call it create element, then it'll be assumed it's from string. And we'll put some documentation. Creates a JSON element from a string, and then string data needs to be formatted correctly. By the way, there's a difference between EX and EG for those who don't know. EX is example, EG is elaborating on what you're saying. I thought I'd point that out because I only learned that rather recently myself, because I've been using EG as if it was an example. And that's just really quickly to define what the format should kind of look like for JSON. And technically you can't, the sad thing with JSON is there's no comments built into it. So the only way to do comments is you have to literally make JSON keys which aren't used for anything. I wish JSON had comments. It would make my life so much more easier. It's actually not what it's supposed to throw. And I don't think there's a, JSON isn't documented very well. Yeah, look at all these exceptions it throws. So what we want to do is I need to go find where the hell I was because I got so much stuff open right now. So we don't need, actually this is exactly what the class we need. This is, put this here, because we want to say it throws a JSON syntax exception if the string is not formatted correctly. And I'll add the other exceptions to this. When you're making Java docs, try to put the exceptions in there. If you know it throws something, put it in there. If you know a parent method you call throws something and you're not catching it, put it in there as well. Because when I'm reading your documentation, I'm not quite sure what your code's doing, but your documentation should tell me exactly what the code does. In this case, it creates a JSON from a string. Here's the JSON. It makes a note that it needs to be formatted correctly. It returns a JSON element, and it throws an exception if it's not formatted correctly. Of course, it's not throwing an exception directly, but one of its parent calls is throwing an exception directly. And that'll work. So what we want to do is JSON loader and create element, and that handles that. And of course, we're just loading in a really crappy JSON element. To be honest, I could do this real quick. I don't need anything but that. You have to have a bare minimum of that for a JSON file to work, if I recall right. It may need more. If it needs more, we just come down here and edit it. But we need a JSON element to test this. So we want to do JSON element equals create test element. Wow, we don't actually use that. So we create test element. That key in something was probably used. If I actually go and find what I just took it from, yeah, we're testing key and name here. So there is like a little system here where we can test to see if that's valid, and that's only used up here somewhere. There's some way that's handled. We don't need our test class. We don't need that. We don't need that. And we don't need that. And we don't need that. So what we want to do is we want to pass an element. And what we are checking, so we don't want object.key, we want object.element. And we want to make sure that, not that these are equal if they're the same object, because we want to make sure that if it's passed in, they're literally the same. Then we want to set object.element to null, and then we want to test the next one. So we're going to test both objects here at the same time. So we got element 1, which is the filled, and element 2 is the method. So that'll run. If we actually run our unit test, these all should function. Yep, that functions. I'm pretty sure this whole system functions, but we're pretty much just double checking everything. And I'm pretty much using this video as an example of how unit testing is done, and pretty much training tool for my interns. I'm hoping to make some actual proper training tools here eventually for them, because most of them don't know how to do the basics. A lot of them are still either in high school or just got out of high school and are just now entering college. and that means their experience with coding is limited to an introductory 101 course or a couple courses. My interns vary in levels. For example, Kalatra, he's really good, although he's not an intern. I think he's either at junior or senior level. I don't remember which. So he codes pretty well. You got Henneman, he codes half decently. He needs some more experience. Green needs more experience. Then we got Poopsicle, who actually knows how to code well, but unfortunately doesn't have time. He's actually going to go be working in Boston here soon. I don't remember what his job is. So unfortunately, a lot of the good interns I have get nabbed up by people. Like Kalatra does more work for the FTP team right now than he does for me. He has converted a lot of our mods to newer versions, though. I actually thank him for that. So next thing we need to do is test integer. This one's going to be straightforward. We're going to pass in the number 1, and then we're going to pass in the number 2 here. And we're just going to check to see if I works in both of these cases. So this should be I, and then this should be I3 is what this should be. And we want to make sure this is 2, and we'll make sure this is 1, and they need to be equals rather than same, because same will never, I don't think, pass correctly on integer. I could be wrong on that one. I'm not too familiar with it. And then we want to repeat this, and then this needs to be 2, and this needs to be 4, and we're going to pass in 3 and 4 in here. This way we don't have to reset things to 0, we're just setting them directly. And if we run this, this should function properly. Did not function properly because we're checking the wrong integer. And yeah, checking the wrong integer. It should work now. Okay. I do want to check my test object real quick because I'm concerned if I actually labeled. No, I did label this one integer. Okay, so we're good there. Yeah, that test integer. And then we repeat this test for short. Luckily, then the preceding tests are going to be a little quicker to create. So the next thing we need to test after integer is byte. Should have went the other way. Should have went like byte, then short, then integer, because that's actually how the size works for them all, but it really doesn't matter. So this will be S, and this will be S2. And then we're going to set these to 1 and 2, and we just need to set this, check to see if both of these work. And then we'll go ahead and we're going to move directly to everything, and we'll test everything at the last second. Not the ideal way to do things, of course. You want to test things as you go, but actually these need to be bytes. B and then B2. That one's short. Test long. And this is going to be a long day, actually. I got nothing better to do than code all day. So this means I get to code all day. That should work. And then we want to test float, and then doubles the last one. So these will be Fs. And then in this case, we want to just do this real quick. And then we want to make sure that they match. By putting an F at the end of something, you declare it's a float. If you didn't, you could actually, the cool thing with float, you could pass in integers, bytes, and shorts into them, and it should work properly. Because of course, an integer or a byte and short will auto-promote to an int, and an int will auto-promote to a float. And then this is a double. So we got D double, and we're checking doubles. And we just put a decimal point on these. And we're actually going to put a 0.1 here. We're going to change this to a 0.1. That'll confirm to see if it's loading doubles properly. And I believe that's everything. And the only thing I got left to test is to see if the JSON parsing works properly. And we broke something. Unexpected error setting, public short, com.builtBroken injection class dot s with 1. Can we actually set shorts? I think we can, but I think what happened is it tried, oh, these are longs. You know what we need to do with these? I gotta put L's at the end of these. That'll guarantee those are longs, and then I'm gonna have to cast these to short. Actually, you know, I wonder, can I put an S in this? No, that's not a thing. Okay. Sometimes you get syntax sugar like we do with the longs, so you don't have to cast them. We'll have to check to see if I have to cast these. And these probably need cast of bytes. Okay, run this again. Okay, it works. So yeah, we just had to cast things, and it looks like the equals check is going to auto-promote things, so we don't have to worry about it as much. This means everything works, and the last thing I got to do is finish testing JSON element. So when you pass in an element, and that element then contains an integer, it loads properly. We can do this a couple ways. I'm trying to think of exactly how to do it. What if we could just make a JSON primitive? That would be the easiest way here. So JSON primitive equals new JSON primitive. See if there's a constructor for this. There is a constructor for this. Okay, so we got Boolean. So we want to do the Boolean real quick. So we want to do true. And what we want to do is just pass this into handle. And are we testing Booleans in this? We haven't tested Booleans yet. So we're going to make a new thing for Boolean so we can test that. I want to call this bool, and we'll call the element bool while we're at it too. And then we'll come down to the methods and we'll repeat that. Okay, so that'll let us test both those, and this needs to be number 2 actually. And we got our primitives. So we got a JSON primitives here, so we can actually test to make sure this is functional. And then our thing's going to default as false. So if we tried to test false read incorrectly, we're not going to be able to do it. We have to test the true read. So we're going to test bool first, and we're going to pass in our primitive. And what we should get is actually I don't need to copy that. I can do this, and I can do. Okay, that gives us our test for that. I need to make a new test for this just to respect the logic flow of how JUnit tests are meant to be designed. You should recreate a test per data set, so that way when you get a test that fails, it fails for a reason. So we want to test JSON Boolean is what we're testing, and this should work. We do need to copy this, and we do need to test a normal Boolean. So we're going to test Boolean is what this is. I don't know if we set the Boolean system to work properly. But we'll find out in a second. So we're going to run these and we're going to see what this does. Cool, everything worked. Yeah, we just got to duplicate this down then. So yeah, duplicating this is not something that's going to be fun. So I need to copy every last one of these, and then I need to paste them, because I have to go through and essentially redo every single one of these by doing this. And JSON primitive oh shit, is there not a number? Okay, so we have to get inventive here, because I need a number, but I don't know what this class is. So I have to do edit, find usage with settings, projects and libraries, and IntelliJ is going to be absolutely mental on me right now. Continue. Did you find me things that aren't even of the same type. I want to facepalm at IntelliJ right now. So what it did is it went through and found everything with the name number. Not everything of the class type number, everything with the name number. So there are things in here that I'm going to have to dig around for. What I'm looking for, though, pretty much this actually. So what are you doing? If int type int value, so we got a type adapter, private type adapter. You return a number, but where do you construct the number? Return Is a number a Java object? Am I misunderstanding this? Oh shit, it is a Java object. I guess I am misunderstanding this. Okay, so this actually quite literally could just be passed in as that. So what we want to do is we want to do this. I almost completely forgot that Java had an object for numbers. People don't understand how Java works, and they're like, everything is objects. Technically, you're right, except that numbers are handled as primitives, and what happens when you pass them around is they're boxed and unboxed. Java has a system called boxing. What it does is it puts something in a box, and that box happens to be the number object, and then it takes it back out of the box when it wants to use it. That's how you can pass things around. It's an automatic system it uses. I bet in the earlier days there wasn't something as automatic about it. It was probably something a lot harder to use. But I don't know the full history of Java because I started using Java about it's somewhere around 3 or 4. I don't remember which. And even when I used it then, I didn't actually start to fully comprehend what Java was until about 6. So about version 6 is when I started actually investigating how Java functioned and how the backend worked and how you did various things and stuff like that. So it's more of a recent thing. And even here, even more recently, so like within this coming or last year, was when I actually got a full introduction in how the Java works and how the backend works and how almost every piece of it works now. I'm still not an expert in Java, but I'm much better off than I was beforehand. Although, seeing as I forgot about the number system existing, that shows my inexperience right there. Okay, I think we're good. Yes, our entire system guaranteedly works. And I want to run with coverage. Okay, so our injection processor, if we open this up, I should get a coverage information about it. Why? Okay. Run with coverage. Why are you not giving me my coverage report? So it's giving me my coverage report on the two classes I'm utilizing, which is of course going to be 100% because you're automatically 100% coverage on a unit test as long as you don't do some weird stuff like put try catches in it. And you're going to be automatic on your test class, which is this. This is going to be 100% coverage because I'm calling every method in here pretty much. But the thing I need coverage check on is this class right here. But it's failing to do this because I probably need to test all the things, which will give me a full coverage report if I actually run it. I'm going to let it run first here, and then we're going to rerun it again to get the coverage report. By default, it doesn't run with coverage report. And what broke? Of course, you're null. Because there is no instance object. Actually, that should have created an instance object. I don't know why that didn't. Um, yeah, that'll work. So this should run again. So we're gonna hit run with coverage. By the way, the test all the things name comes from my buddy Grogger, who has a lot of jokes like that, like break all the things and stuff like that. And it comes from the all your base belong to us joke. That's where it stems from. So I named my thing test all the things. And we already have a failed test, so this might take a bit longer to run with the code coverage check. I rarely run this anymore because if you heard me complain about how my launch time takes 5 minutes sometime, with coverage on, it takes 20 minutes usually. Probably not the brightest idea to run this full thing. Hopefully it doesn't crash on bitmask wrapper test. It's done that a few times. It's one of our Scala classes, and I kind of want to get rid of it. I do have to admit, though, it does work really nicely. Scala's got some cool features like auto wrapping. Like if I wrote my entire thing in Scala, I could write a system that auto wrapped all of my classes for me automatically. So I could treat non-tile entity objects like they were tile entities simply because Scala has that functionality. We used to wrapper a lot of things. Like if we wanted to use an entity and we wanted to use it like a position data object, we could wrapper the entity in a position data object. To do that in Java, I would have to make the class. Of course, I think Scala is doing that. I think it's how it actually functions. Is it actually just writes the class for you? Because of course, when you want to wrapper something, it's not as simple as saying this is now wrappered. You do have to actually write the wrapper logic, which is what bitmask wrapper does. It wraps the byte buff, I believe, inside of a utility where I can actually do things. Yeah, so we got open mask, closed mask. Actually, I'm thinking about this wrong. This isn't our byte thing. This is our bitmask system. Our bitmask system is designed to take a byte and to pretty much use it for directional stuff. And I don't think this is used anywhere in my code anymore, so I could probably get rid of this. Now I'm going to do on this. Can I fail this? I don't know how to fail the test system for this. As you can see, this is still written by Calclavia. I think I've only come in here and maybe adjusted like 2 or 3 things just to make stuff continue working. But the bitmask system is his system. I don't usually use the bitmasks because they take a bit of effort to use. It's really cool to be able to compress something down into a byte because that gives you 255 state opportunities for something that only takes a byte. Where if you use an integer is multiple bytes. If you use a string or use booleans, like a boolean by itself is a single byte because the smallest unit of measurement that you can actually have in a data structure is a byte for Java. You can't go any smaller than that. I think a lot of other languages are just like that. You can't go any smaller than a byte because memory can't go any smaller than that. Usually you store on your RAM stick in bytes. You can access bits, but in order to access bits, you have to load the byte and then access the bit out of the byte. So when we utilize the bitmask, we can store really complicated data, which we were using for wires. It was literally created for wires is what it was created for. We had earlier versions than that, like ICBM's camouflage block uses a byte mask to do its state systems. A lot of our rotation code did end up using bytes for that because it's a nice way to store stuff. I don't have to store an integer, which if you use an enum, you're storing an integer, if I recall right. I could be wrong on that. Feel free to correct me. But that means you're storing multiple bytes, so it's increasing your memory load. It's not that big of a deal when you're using Java, because I mean Java cleans up after itself, but when you want to write really high performant code, you need to keep in mind things like this. And why is this taking so long? Where are you even running at right now? At least I ran the page builders. Oh, here we go. It's running missile station tests right now. Yeah, we have tests for the missile station. I don't have tests for everything in ICBM, but this is one of the things we do have tests for. And this is mostly to test, even though it looks like it's testing a lot of things, a lot of these are empty methods actually. The thing it's mainly testing on is, you know, actually I want to, how do I go to this? Okay, I don't want abstract tile. One of these is not like the other. There's a high likelihood that it actually is not testing anything. Can I not navigate to the class? Jump to source. That's going to take me to the abstract tile test. So this is the thing why it looks like it's running a lot of stuff, is because we have an abstract tile test object which tests every single method possible in the tile system in order to ensure that just by simply calling it, we don't crash. It's actually saved a lot of errors and issues. It's caught a lot of bugs and problems with the system. It's one of the beauties of doing things. Oh, here's test missile. We can go take a look at that. And this would quite literally just test toString. This is why I need more JUnit tests. Here's test cool engine. This actually does have code in here. This is for crafting recipes is what this tests, to make sure the crafting recipes work properly. Or rather, item loading into the engine works properly. It actually does work. I mean, it's never failed. There's warhead testing. Then again, this is another example of where we're testing primarily everything, pretty much. Our basic inventories are tested highly to ensure that our inventory code runs. Energy buffers are tested to make sure that they run properly. You won't find a lot of mods that have tests in them. But when you implement tests and you implement them properly, they make bugs less likely. And so far this has been proven to be true because we rarely get bug reports, although as I've noted to other people, that could be the case of we just don't have anybody using our mods. Crap, I just threw the tea bag across the room and it missed the trash can. Even though I got a small room, it's still easy to miss a throw like that. We're almost to the bottom. This is probably taking forever. I think I have high level code coverage check turned on, which means it's doing a lot more than it really should be. Probably could just run a basic level. We have tests for the guns too, like gun data loading and saving is in here. This ensures that the gun objects function properly. Even though you see a lot of nulls in here, this just checks loading. Eventually all the guns in pretty much every one of the objects in Armory is probably going to be heavily tested. JUnit testing, or not JUnit, JSON loading is going to eventually be 100% tested, because if that fails, everything fails. That's how highly dependent the system is. When you do JUnit testing, one of the things to remember is always test your most used object, because if it's if it's an object that's only used a couple times, there's not a lot of point testing it. But at the same time, you could use the reverse object. If an object is used excessively, the likelihood of it failing is not very high. But you still want to do it anyways. That's why the case, the pause system is tested heavily. Like right here, we've got, or actually, what happened to the test case? Actually, I know where the test cases are for this. All the test cases for this is in the coding lib. The only thing we're doing here is testing equality, and this is probably not even, yeah, this is the pause system for the profiler. So the profiler's got its own pause system because it's meant to be an independent mod from VoltEngine, because I'm building it to test VoltEngine primarily. I'm trying to also build it for a client, but unfortunately ASM is not working in my favor, and I need to make JUnit test to do ASM testing, but I haven't figured out how to do that yet. Once I do, then that system will probably start working properly. And come on, run faster. I'd say I break out the whip and hit this with something, but I'd break my computer. And it won't go any faster. I could try to kick my computer into turbo, but I think turbo is an auto system. Yeah, it's not even a CPU issue. Here's how you test if it's a CPU. Here's actually how you test to see if you've hit the limit on an application's capability. Is you take a look at the CPU usage. If you see a CPU hit 100%, then there's an application maxing your CPU. We're looking good, and my CPU is running at max 100 to 1 max frequency. I actually probably should set my CPU up to throttle itself down automatically, but I don't think it's important. At this point, it's just the fact that IntelliJ is running slow, so the software itself is the problem, not the computer. And that seems to be normal for IntelliJ these days. At least that's its default setup. There's probably ways you can tweak this and change it. Like, there's people who know how to use IntelliJ better probably know how to make this work better. Unfortunately, my experience with IntelliJ has been limited to just using it as a text editor. Like, I could quite literally just go back to using Notepad right now, and the difference would not be massive. The only real reason I actually use things like IntelliJ or Eclipse is I get Santex highlighting, I get autocomplete, TrueType, which basically detects for errors, and then I get a package navigator on the left side. So if I have another application that does all of that for me, I would easily switch to it. Add to active suits. Okay, here we go. This is what I've been waiting for. So as a whole, everything I have has a class coverage of 23%, 19% method coverage, 18% line coverage. Line coverage is really hard to get to 100%. Class and method, not so much. Class is really easy. You just got to make a JUnit test per class you have and just call something in it. Methods are really easy. You just got to call your methods. Line coverage actually will check exactly what you're testing for, and it'll check to see how your test goes through each line, and will ensure every if statement has been checked, every variable, every error, everything. And there's only been a few cases I've got this, and the only time I've actually really done it is for school assignments where you're required to be 100% tested. The irony of it is in real life, it's rare to be 100% because it's not cost efficient. It's a waste of money to hit 100%. So we are testing, and I think I went up a package too high. So what we were looking for, we're looking for the Json system. So I need to get out of Coding Lib. So I want to go in here, I want to go MC, lib, JSON. So the thing is, our content loader is we're 66% method and 59 or 58%. So if you actually open this, how this looks is you'll see green on the side. In areas where we're not tested, you'll see red. So we haven't tested claim content because there's not a lot of easy ways to test that. We're missing a few if conditions here, like data is never null, to be honest. This is almost a never happens thing. So in order to actually start testing a lot of this stuff, you start having to feed junk data into your application. And a lot of these places, it's almost impossible to feed junk data in here. Like this whole entire thing is not even tested, like load resource isn't, because load resource depends on having access to the file system, and I try to avoid giving my JUnit test access to the file system. The reason for that is it junks up your file system. I have this issue with actually running my JUnit test as it'll generate so much stuff because I actually start a live Minecraft server and just turn off its thread taking system. So I can actually mess around with the Minecraft server. That's the reason why some of these JUnit tests take a while to run. But we got that. So what we were actually looking for is to see how our processor is unit test. Yeah, so we're missing a few things here, like we're not doing null checks. Yes, but we have hit a majority of our systems. We just haven't handled any exceptions. I'll do that on my own. There's no point in showing you how to do that. What it does come down to, if I actually was to note it, is you would intentionally feed bad data into your system, and you would put a try catch to catch the error. And if it does not catch the fail, you want to fail the test. In this exact case, I will do one error to show how this works. So public void test bad JSON. So we'll make this up real quick. And we want to test one of our JSON primitives, except actually, so we're first test we're going to do. So we're going to do a try catch. You're going to do fail, but we want to do object dot. No, we don't want object. We want map dot handle object key and then null. This should fail, is what this should happen, or rather, it should crash, is what it should do. So we want to go else, and we want to go runtime exception e, and we don't want to do anything with this. And actually, this needs to be a catch. So this is a success. If we get a runtime exception out of here, it's a success. Now, what you can do in here is also to make sure that the exception you're actually getting does match your exception, but this is a success for that test. And if we grab that real quick, put this here, and we can run just this test, so we don't have to run them all. That's the reason why I want to migrate back to using just plain JUnit, is because you can run individual tests. So we didn't get a null here, and we should have got a null. Okay. That actually surprisingly is valid code. That's stupid. So what just happened is I went to go set a string variable to null, and it actually worked because you can set a string variable to null. So we got caught by this part, and it functioned properly. So that's not bad data. We just passed in good data. Actually, yeah, we passed in good data. That's surprising. So how do we handle this? I'm trying to think of an exact case where we would have. Okay, so we got a JSON element. JSON elements are handled by default by this system here. And if we get a primitive in here, and the thing is, the primitive data is always going to be good. The only thing we can do now is to define bad objects. But I'm going to end the video here, and I'll figure this stuff out on my own here off camera. Because for the moment, that system is actually more resilient than I thought it was.